Hi everyone, this is your math guru. In this video, I'm going to show you how to solve or simplify the trigonometric values that are represented by letters. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. When a trigonometric value is represented by a letter, other trig ratios or expressions can be written in terms of the given letter by using your reduction, cofunctions, trigonometric ratios, compound or double angles, and basic trigonometric identities. In the example given, we have if cos squared 23 degrees is equal to t. Write the following in terms of t. A sine squared 337 degrees, B sine 23 degrees, C cos 46 degrees, D sine 46 degrees, E tan bracket minus 226 degrees, and F sine 37 degrees. Starting with A, we have sine squared 337 degrees. Note that because we are trying to write in terms of cos squared 23 equals to t, we are writing in terms of t, we need to reduce our angle such that we have the 23 degrees reflecting in whatever angle we are given. So in the first example that we have sine squared 333 degrees, the first step is how can we reduce 337 degrees? I'm going to change that to sine squared 360 degrees minus 23 degrees. Note that if I go back to my cast diagram, as shown, I have my CAST showing the trig ratio that is positive in each quadrant. We have my theta, I have my 180 degrees, minus eta, 180 degrees, plus theta, and 360 degrees minus theta. Note that the angle 337 degrees falls in the fourth quadrant, so the code for reduction will be 360 degrees minus theta. And if you look at it, 360 minus 23 will give us 37 degrees. And already I have my 23 degrees reflecting. Now, if you look at that quadrant, only cosine is positive. Sine is negative in that quadrant. So what that means is, if I have sine 360 degrees minus 23 degrees, using that, I have sine negative in that quadrant, so it's going to be minus sine 23 degrees. And because my angle is being squared, what that means is I have sine squared 360 degrees minus 23 degrees equals, I'm going to square that, so that will be minus sine 23 degrees all squared, which is equal to positive sine squared 23 degrees. So going back to my quadrant, in order to draw that, I have the angle 23 degrees, which is acute, in the first quadrant. I have that as 23 degrees. And note that from the first part of the question, where we have cos squared 23 degrees equals to t, I have cos squared 23 degrees equals to t. To find cos 23, I'm going to find the square root of both sides. So that means cos 23 degrees will be square root of t over 1. Also, from our trig ratios, cos or cosine is adjacent over hypotenuse. So what that means is, if I go back to the diagram, the side facing my angle is my opposite, the longest side is my adjacent, A, and then the longest side is my hypotenuse. I'm going to correct that. That's the side facing the 90 degrees is my hypotenuse, and the third side is my adjacent, which is A. So if I'm filling in the values, I have cos 23 degrees equals adjacent. Adjacent is now equal to roots of t over hypotenuse. Hypotenuse is 1. The next step is to find opposite. To find my opposite value, I'm going to use my Pythagoras theorem because that's a right angle triangle. And for my Pythagoras theorem, I have hypotenuse squared equals opposite squared plus my adjacent squared. Making my opposite the subject of formula, I have opposite squared equals hypotenuse squared minus adjacent squared equals hypotenuse, that's 1 squared, minus adjacent root of t all squared. Therefore, my opposites, finding the square root of both sides, that is equal to 1 minus t, will be square root of 1 minus t. So I'm going to put that here. Opposite equals square root of 1 minus t. So going back to our sine squared 23, we have sine squared 23 degrees equals, sine is opposite over hypotenuse, so I'm going to square that. So that will be O over H all squared, which is equal to opposite, that's root of 1 minus t over 1 all squared. And my final answer will be 1 minus t. So, in summary, we've been able to move from sine squared 337 degrees, it's equal to sine squared of 23 degrees, which is equal to 1 minus t. Let's go to the part B, which says, write in terms of t sine 23 degrees. From our trig ratio, sine is opposite over hypotenuse. So using the same diagram that I had for the first part of the question, my opposite, that's the side facing the angle or the reference angle, that's root of 1 minus t over hypotenuse. Hypotenuse is 1. So therefore, sine 23 degrees equals square root of 1 minus t. So I have that as square root of 1 minus t. The third part, I'm to find cos 46 degrees. Cos 46 degrees, that's a C. Note that the aim is to always work towards angle 23 degrees. 46, that's a multiple of 23 degrees, so I can rewrite that as, and that is equal to cos 2 times 23 degrees. So using the double angle identity for cosine, that's equal to 2 cos squared. The angle given, that's 23 degrees minus 1. Note that the question says cos squared 23 degrees is equal to t, so I'm going to replace that. That's cos 46 degrees equals 2 times t minus 1. So that's equal to 2t minus 1. The next part of the question says sine 46. So I'm going to do the same thing. I have d sine 46, that's also double angle identities. So I have sine, that's 46 is a multiple of 23 degrees. So that's 2 times 23 degrees. That's equal to 2 sine 23 degrees cos 23 degrees using the double angle identity. And that's equal to 2. Note that sine 23 degrees equals root of 1 minus t. So I have 2 times square root of 1 minus t, close bracket. And then cos 23 degrees is root of t. What I've done is we're given cos squared. I'm going to work that out here. Cos squared 23 equals to t. So finding the square root of both sides, I have cos 23 degrees equals to t. Oh, I'm going to adjust that. Cos square root of Oh, okay, that's t, and then I found the square root of both sides. Okay, so therefore cos 23 degrees is equal to square root of t, and that's what I have here. So therefore, simplifying my expression, I have that as being equal to, I'm going to take in the t, applying the surd rule. So I have 2 square root of, I have t multiplying 1 minus t. So therefore my final answer, 2 square root of t minus t squared. The E part says we should write in terms of t tan of negative 226 degrees. Using my cast diagram, note that I have my theta, or 360 plus theta. I have in the second quadrant 180 degrees minus theta, third quadrant 180 degrees plus theta, and 360 degree minus theta. That's my cast diagram. Because it's a negative angle, I want to make it positive. It's in the minus 226 will be in the second quadrant. But to confirm that, I have 10 minus 226. I'm going to add 360. So that will give me 10, 134 degrees. And that's in the second quadrant. Note that in the second quadrant, the value of tan is negative. And the breakdown, I'm going to use 180 minus theta to do the breakdown. So that's equal to tan in bracket 180 degrees minus 46 degrees. Note that the aim is still to work towards my 23 degree angle. So writing that, I have that as, because tan is negative in the second quadrant, so that's negative 10, 46 degree. That's a double angle, so I can write that as minus 10, 2 times 23 degrees. Now using the double angle identity for tan, that will be equal to minus 2, 10, the angle, that's 23 degrees, divided by 1 minus tan squared, 23 degrees. And using the diagram I have my hypotenuse 1, adjacent root t, and opposite root 1 minus t. Tan is opposite over adjacent. So that will be equal to, for my numerator, minus 2 multiplying opposite, that's root 1 minus t, over adjacent, that's root t, all divided by, I have 1 minus, I have the same thing, tan of 23 degrees, all squared, 1 minus t over root t all squared. I'm going to rewrite that properly here. Simplifying further, I have that's equal to minus 2 at the top for my numerator. I have root of, I'm going to put that under the same root to make it easier. Or better still, separate my numerator and my denominator because of the double fractions. So I have minus 2 root of 1 minus t all over root of t divided by, I have 1 minus, in bracket. If I find the square of what I have there, applying the surd rule, that will be 1 minus t divided by t. If I simplify further, I have that is minus 2 root 1 minus t over root of t. I'm going to work that out by the side. I have 1 minus, in bracket, 1 minus t over t. That's the same as t over t. I'm going to make the denominator the same, minus 1 minus t over t. And because the denominators are the same, putting them under the same denominator, at the top I have t minus 1 plus t, which is equal to 2t minus 1 all divided by t. So going back to my calculation, I have divided by 2t minus 1 all divided by t. And applying the fraction rule, that's minus root 1 minus t over root of t times, then I'm going to flip the right hand side, that will be t over 2t minus 1. If I merge the numerator, that will be minus t squared. I'm taking the t under the root also, so that's t squared minus t3 divided by, I have root t to t minus 1. And if I apply the sort rule, taking the root t at the bottom to the top, my final answer will be, I forgot to include my negative 2. That's minus 2 is missing here. I'm also going to add that on the next line, that's negative 2. So therefore, my final answer will be negative 2, putting the root t at the bottom to the top, that's going to divide, so I have that as t minus t squared, all divided by 2t minus 1. That's a long one. For the final one, I have f, find sine 37 degrees. So I have f, sine 37 degrees. Note that it's still back to rewriting or reducing using 23 as a reference angle. So if I rewrite sine 37 degrees, that's equal to sine of 60 degrees minus 23 degrees. 60 minus 23 is 37. And using the compound angle identity for sine, that's equal to sine alpha, that's sine A is 60. So I have sine 60 degrees cos B, that's cos 23 degrees, minus cos A is 60, then sine B, that's B is 23 degrees. That's equal to, using my special angles, sine 60 degrees root 3 over 2, multiplying cos 23 degrees, we've been able to establish that as square root of t, then minus cos 60, that's 1 over 2, times sine 23, we got that as root 1 minus t. So putting that together, because I have the same denominator, that's 2. At the top, I have root. The rule says if I have square root of a times square root of b, the sort rule, that's the same as square root of a times b. So I'm going to merge my numerator here. That will be square root of 3t minus root 1 minus t, all divided by 2. Thanks for watching. Bye.